about custom capsule constructors. So as you saw in last sprint demo, we have now support for adding constructors for capsules. So you create them in exactly the same way as you do for classes. So right click and do add UML special operation constructor. You will then get a constructor that has two mandatory parameters, the RTG_RTS and RTG_ref. The first one is the controller, that is the thread that will run the created capsule instance. And the second one is the capsule part where the created capsule instance will be inserted. Those two you should never modify because they are mandatory and are used by the target RTS and actually also used by the model compiler to recognize this capsule constructor. But after those two, you're free to add as many user-defined parameters as you want. So in this picture, we've added another argument called P of type unsigned int. And you can use this feature to add initialization data or pass initialization data to a capsule instance already at the time when it's created. As you know, previously, it was only possible to send such data within the initialization event that is received in the initial transition of the capsule state machine. But that is sometimes too late. And for example, if you have a reference variable, then you need to initialize that already in the constructor, and that you now can do. And also, this now works for all kinds of capsule parts, not just optional ones. So you can have fixed capsule parts and have these constructors defined on them. So let's take a look in the tool how we can create a constructor. So here we have a capsule called A, and we have an attribute _A, which is of type const std string reference. So to initialize this string variable, we would need to use a constructor. And we can create it by doing add UML special operation constructor. And here we got it. And as you can see, it has these two mandatory parameters that you shouldn't change. But then you can just create any other parameter that you like. So for example, we can create one parameter called A, and we can use the same type as the variable we want to initialize. So in this case, we would need to use a constructor initializer for assigning, for initializing the _A. And that we do as usual like this, but we also then need to remember to initialize the base class by calling RTActor constructor, and here we should pass these two mandatory arguments that we always have, like this. So this is the same thing you all need to remember when working with passive classes, that you have to remember this initialization in case you use constructor initializers. And that should be it. So then we can just build the transformation configuration. Like that. So how then did this work? Well, the answer is that we need to know about capsule factories to understand how the target RTS can invoke these custom capsule constructors. And the concept of a capsule factory was introduced for exactly that purpose, so that we can invoke custom capsule constructors. And the capsule factory specifies two things. It specifies how capsule instance should be created and how it should be destroyed. And you can provide a capsule factory in various ways. And if you do it in multiple ways, then there is a defined priority where we will look for which one to pick. So it's kind of an hierarchical manner. The simplest, and that what I used in the demo you just saw, is to write a create function body on the capsule part. So that is a new code snippet that we have introduced. There is also a destroy function body, but that one we don't need to specify in this case, because by default we will use the regular delete operator for deleting the capsule instance. And as you can see in the screenshot here, we simply write the code by returning an instance of the capsule, and when we invoke the new operator, we can also specify the argument that we need to pass to our constructor. The second place where you can specify a capsule factory is in the property page for a capsule part. So there is a new property called capsule factory, as you can see in the second screenshot. This property will be looked at if you haven't specified a create function body or destroy function body. And this is useful if you want to implement your own capsule factory. So write your own class that specifies the create and delete function. Then you give the address to an object of that type here in this field. And in a similar way, you can do it globally on the transformation configuration levels. There is a new TC property where you can specify the same thing. And in that property, you can also use a variable called capsule underscore class, which will be expanded to the name of the class that the model compiler generates from the type of the capsule part. So for example, it can be used as a template argument, like in this example in the bottom right of this slide. So let's take a look at the sample that we just built to explain how it worked. So if we look here in on this capsule part that is typed by our capsule, on the top capsule, we see in the code view that we have a create function body. And here we specify the first two arguments as always, but then the last third argument here is the string we want to pass to it. And here you can see an example of how we can access, because here we want to pass this attribute that contains the value hello to this constructor. And to do that, you need to use the rtd-ref variable and call getOwner. That will give you the capsule instance that owns the capsule part. And then you can cast that to the correct type and access the variable like that. The reason for this is we can understand if looking in the generated code, because there will be one capsule factory generated here that is actually a static object. So you can see this is the static capsule factory that is associated with this capsule part. And then we get a small class here that contains the create and possibly the destroy code snippet. So the other place is this property that I mentioned down here, capsule factory. So if you have your own capsule factory class implemented, you can reference it here. And the last place I mentioned was the transformation configuration. Then it's in this code generation tab down here, and we will see an example later on how we can use that. And there is another thing to mention, and if you have an optional capsule part, we have added another version of the RTFrame incarnate function. We call it incarnate custom since there was already quite many overloads of the incarnate function. And incarnate custom works exactly like incarnate, except that it takes an RT actor factory as argument. And this RT actor factory allows you to customize how to create the capsule instance, but not how to destroy it. And the reason we did that was that we didn't want to have the overhead of keeping track of, for every capsule instance, which capsule factory that was used for creating it, so that we could use the same for destroying it. So if you use optional capsule parts, you can customize how to create the capsule instance, but not how to destroy it. It will always be destroyed using the delete operator. You can do it in a convenient way using a lambda expression, like you can see here. So you can actually construct the RT actor factory by providing the function that will be used for creating the capsule instance. So in this example, we show how to invoke a user-defined constructor that takes an integer as the third argument. So if you have capsule factories defined in many places, there is a priority order in which we will pick them. So the first priority or highest priority is this incarnate custom. If that is not specified, we will look next in the create and or destroy code snippet on the capsule part. After that, we'll look in the capsule factory property on the capsule part. And if we didn't find a capsule factory in any of these places, the last place to check is in the TC, in this new capsule factory property. And if you don't find a capsule factory there either, then it will fall back to the same behavior as it had previously. So it will basically, then it can only invoke create the capsule using the standard 2-argument constructor. Also, I'd like to show you where in the documentation you can read more about this feature. Let me take help content here. There is a new article in the user guide. So if you go to articles and modeling real-time applications, you find the article called Custom Capsule Constructors that covers basically what I just demoed and also a little bit more.